Hello everyone, in this video I'm going to talk about how to split any network into two subnets and then how to find the range of IP addresses in each subnet. When you plan IPv4 addressing or when you do subnetting for an organization, you may need to split a network into two equal hubs. It is really important to understand which IP addresses go in the first half or the first subnet and which IP addresses go in the second half or the second subnet. In other words, what will be the range of IP addresses in the first subnet and what will be the range of IP addresses in the second subnet. I'm going to explain how these numbers work. I will use one example for each of the class A, class B and class C addresses. So let's take an example of a class C network address 190.160.34.0 and the subnet mask is /24 or 255.255.255.0 in dotted decimal. Since the subnet mask is /24, that means we have 24 network bits. That gives us 32 minus 24, that means 8 host bits. 32 is the total number of bits, 24 of them are network bits, so there are 8 host bits. If you have 8 host bits, that gives you 2 to the power 8 equals to 256 IP addresses, and those IP addresses will be 190.160.34.0 is the first one, 190.160.34.1 is the second one. For convenience, I'm writing them without repeating the first 3 octet, and then first 3 octet will be the same for all of these IP addresses. 190.160.34.0 is the first IP, .1 is the second IP, .2 is the third IP, and keep going. It goes up to .255 is the last IP. So I would say the range of IP addresses starts from .0 and goes up to 255, but keep in mind that the first 3 octets are 190.160.34. Right. Now I want to split this range of IP and find the midpoint so that I can say which IP addresses go in the first half and which IP addresses go in the second half. There is no exact midpoint because the number of items here is 256, which is an even number, but we can find the last IP of the first half and the first IP of the second half easily. Let's take a simpler example. Let's say we have the numbers starting from 0 to 15. Let me write it down again. 0 to 15. Okay, and then I want to split these 16 numbers. Here we also have a even number of items, 0 to 15, that gives us 16 numbers. Now it's easy to find the midpoint. I would rather say it's easy to find the start of the second half. We can use this generic formula where you start with the lowest number, in this case 0, and then plus we have the highest number, which is 15, minus lowest number, which is 0, plus 1, and then divide this sum result by 2, and that gives us the midpoint, which is not exactly the midpoint but the start of the second half. In this example we have 15 plus 1, 16 by 2, which is 8. So 8 is the start of the second half. When we split this series of numbers starting from 0 to 15, then the 8 would be the midpoint, but it's the start of the second half. So now we'll split into 2, and if we count the number of items on the left half, we have, for the first half we have 8 numbers, 0 to 7. 0 is also counted, so 8 numbers, and 8 to 15, which is also gives us 8 numbers. Now if I split the first half again with the same equation, the lowest number plus the highest number, which is 7, minus the lowest number, which is 0, plus 1, and divide this result by 2, and that gives us again 8 by 2, which is 4. So 4 is the start of the second half. If we split these numbers, then 4 would be the start of the second half. So 0 to 3 would be the first half, and 4 to 7 would be the second half. And we can see that there are 4 numbers in the first half and 4 numbers in the second half. Now if we take another example, which is 8 to 15, if we take 8 to 15, then again we start with the lowest number plus the highest number 15 minus the lowest number 8 plus 1 divided by 2. That gives us 8 plus 16 minus 8, 8 by 2, for 8 plus 4. That gives us 8 plus 4, which is 12, and this is the start of the second half. So you split this into 2, and we see that there are 4 numbers in the first half and 4 numbers in the second half. We got this number, the start of the second half, by using this equation. The highest number minus the lowest number plus 1 divided by 2 plus the lowest number, and that gives us the start of the second half. Now we can apply this formula for any case. Go back to our original IP range, starting from 0 to 255 on the last octet. So the start of the second half, if we split it into 2 equal halves, then the start of the second half would be the lowest number plus the highest number, 255, minus the lowest number plus 1, and then divided by 2. That gives us 256 by 2, which is 128. So 128 is the start of the second half. That means 0 to 127, 0, 1, 2, and then up to 127 would be the first half, and 128, 128, and then 129, and up to 255 would be the second half. We have 128 IP addresses in the first half and 128 IP addresses in the second half. In other words, the first half IP addresses will be 190.160.34.0 is the very first IP address in the first half, and then 190.160.34.1, and then 190.160.34.2, and keep going, and then I will come up with 190.160.34.127 is the first half of the IP addresses from this network. Alright, and then the second half of the IP addresses start from .128 on the 4th octet. So 128 and 129 and 130, and if you keep going, end with 255 is the last IP in this range. Okay, midpoint, which is 128, and then the next one is 129, and then the next one is 130, and if you keep going, you will come to the very last IP address of the given range, which is 255. Alright, so we have this range in the second half and this range in the first half. Okay, if I split the second half of this IP range and split into two, what would be the midpoint? We can take this example. So the number starts from the first three octets are the same, so I'm focusing on the fourth octet only. So the lowest number is 128 plus the highest number is 255 minus 128 plus 1 divided by 2. That gives us 128 plus this is 256 minus 128, which is 128 divided by 2 is 64. So 64. That gives us 192. So 192 is the start of the second half if we split this range of IP address. Okay, so 128, 129, and then 192 is the start of the second half, so the first half will end at 191, and the start of the second half would be 192, and then 193, and then 193, and then 194, and goes up to 255. So first this range was split into two equal halves, and we got 0 to 127 in the first half, 128 to 255 is the second half. Now to show another example, I'm splitting this IP range 128 to 255 into two equal halves. So the midpoint is 128 plus 255, the highest value minus the lowest value, 128 plus 1 divided by 2, that gives us 192, which is not exactly the midpoint but the start of the second half, because it's a even number of items, so there is no exact midpoint, but 192 is the start of the second half. So the first half starts from 128, goes up to 191. The second half starts at 192, goes up to 255. I'm not splitting this up again, you can find it out easily in the same process. So that's about leading a class C network, and also you saw how to split not a complete network, but already we have a subnet which is half of a network. That means you already did a subnet and then split into two. Now let's take this class B example. So network is 170.210.0.0, and this is /16. That means we have 16 network bits, or the first two octets are network bits and the last two octets are host bits. So the list of IP addresses in any network would be all possible combination in the host bits. So if you start listing the IPs, we'll have 170.210.0.0, and then 0.1, and then 0.2, and if you keep going like this, it will come 170.210.0.255. But this octet is also host bits, so the next IP is 170.210.1.0, and then 1.1 and 1.1, and then if you keep going, you will come up to 170.210.1.255. but that's not the end. It's it goes up to all possible combination. So for 0 on the third octet you have 0 to 255, all possible values in the fourth octet. For 1 in the third octet you have 0 to 255, and for 2 in the third octet you have 0 to 255 on the fourth octet. And in this way you can keep going, and the third octet would be 255 at the end, and for 255 on the third octet you will have 0 to 255 in the fourth octet. So the last IP will be 170.210.255.255. so these are all possible combinations starting from 170.210.0.0 and goes up to 170.210.255.255. Now look here, how many IP addresses are there? We have 256 IP addresses for 0 in the third octet, again 256 IP addresses for 1 in the third octet, and 256 IP addresses for 2 in the third octet. And if you keep going, you have 256 different values on the third octet. So 256 different values on the third octet, and for each of these values in the third octet you have 256 values on the fourth octet. So that gives us total in this network 256 times 256 IP addresses, which is 65,500. Let me check with the calculator. 256 times 256, that gives us 65,536. Interestingly, you could find the same information, how many IP addresses are there in this network, by using the equation 2 to the power h, where h is the number of host bits, and in this case we have 16 network bits. That means we have 32 minus the 16, the remaining bits of 32 bits will be the host bits. That means also we have 16 host bits. That gives us 2 to the power 16. And if you use a calculator and calculate this to the power 16, you will also get the same value, 65,536 IP addresses. So you can calculate in either way to find the number of IP addresses. Alright, so the IP address range, I'm gonna write it down, 170.210.255.255. Now if you split this range of IP addresses, the most significant in this range, the most significant octet in this range is the third octet, and the third octet value ranges from 0 to 255. So the midpoint again on the third octet would be in between, the midpoint of 0 to 255. Again we use the same formula, the lowest value plus the highest value 255 minus the lowest value 0 plus 1 divided by 2, which is 128. Now this 128 is the start of the second half, but this 128 is on the third octet. How about the fourth octet value? So the fourth octet value will always be 0 if you have this split on the third octet, or if you have a split on the second octet, then the third and fourth octet will be 0. So the start of the second half of this IP range would be 170.210, and then we got 128.0 is the start of the second half. Alright, so the first half IP range is the start of So the IP range, all the IP addresses before this number starting from 0.0, all the IP addresses before this start of the second half will be in the first half. So if I write the first half range .10.0.0 and goes up to 170.210, what is one number before this 128.0, the IP address before this one? Most of the cases, a student to make mistake, they think that it would be 127.0. Not really, it's not 127.0, because if you have more IP addresses between 127.0 and 128.0, the IP address is 127.1. It's lower than 128.0. You have 127.2, 127.3. So you can go up to 127.255, and then you can't increase anymore. The next IP address is 128.0. So this is the range of the first half when you split this IP range, or when you split this class B network. So this is the first half. First we got the start of the second half, and then we found out the last IP of the first half. So the second half starts from 128.0, and the second half ends same as the end of the original, which is 170.210.255.255. Okay. Now let's let's split this once again. Let's split both of them once again. Okay, let's say you're given a range of IP addresses this, or somehow you got this range of IP addresses and you want to split it into two. So what is the range? Look at the most significant octet where you have different numbers is 0 to 127. So in this range 0 to 127, if you use the same equation as before, 0 plus 127 minus 0 plus 1 divided by 2, which gives you 128 by 2 is 64. So this 64 is the start of the second half if you split this range on the third octet. Okay, so your first half would be, I have to make correction here, and the start of the, the start of the second half is 64.0 and goes up to the last IP in the range that we had before, so 127.255. Okay, and then the first half, the end of the first half is one address before this IP address. So what is one address before this IP address? It's not 63.0, it's 63.255, and the very next IP address is 63. The very next IP address of 63.255 is 64.0. So if you split this range into two equal halves, I got these two. Now you can also split the other half. Alright. Let's split this half. We have this. Now again, what is the midpoint between 128 and 255? we start with 128 plus 255 minus 128 plus 1 divided by 2, which gives us 128 plus 256 minus 128 is 128 divided by 2 is 64. So 64, which gives us 192. So 192 is the start of the second half when we split this. Okay, so I'm going to put the first half range starts from the beginning, 170.210.128.0 and goes up to 170.210. I'm going to fill this up later, but we already know the start of the second half. So 170.210 dot start of the second half is 192.0, and end of the second half, of course, is the last IP in this the original. So it goes 170.210.255.255. Okay, now the end of the first half is just one address before this IP, which is it's not 191.0, it's 191.255. Okay, alright, so this is our original range, and then we split it into two. This is the first half, and this is the second half, and then we start with the smaller. Okay, this is the second half, and let's say we start, you are given this IP range, and then you split it into two. You get, this is the first half and this is the second half. Or if you are given this range instead, then you can say, and then you split into two. This is the first half and this is the, okay, I didn't fill this up, so I'm gonna fill up 170.210.127.255. Let's take class A network address. The network address is 50.0.0.0, and the subnet mask is /8. That means there are 8 network bits, as total number of bits is 32, so that gives us 24 host bits, or these 3 octets. Different combination of these 3 octets would be different IP addresses in this network. So it starts from this lowest number and goes up to 50.255.255.255. Now 50.0.0.0 is one IP, 0.0.1 is another IP, 0.0.2 and 0.1.0, 1.2, 1.3, 1.255, and 0.1.0.0, 1.0.1, 1.0.2, and keep going, 1.1.0, 1.1.2, and if you keep going, then you will see there are 256 IP addresses for each values of these third octet, and there are 256 different combinations for each value on the second octet. There are 256 different combinations on the third octet for each value on the second. So the total number of IPs would be 256 times 256 times 256. Anyway, we want to find the midpoint of this IP range. The first octet is the same. The second octet range from 0 to 255, so the midpoint would be after seeing the first two examples, I guess you already got the midpoint. So 0 plus 255 minus 0 plus 1 divided by 2, which gives us 128. So this 128 is the start of the second half on the second octet. Okay, so the start of the second half would be 50.128.0.0, start of the second half, and the end of second half is of course the last IP. So 50.255.255.255. So this is the second half of the network. When you split it into two equal half, the first half of start is of course the first IP that is given as the network address, and then it goes one address before this one is the last IP of the first half. So 50.127, it's not 0.0, it's 255.255. Okay, so this is the range of the first half and this is the range of the second half. Now just to give another example, I will split this half into two. Okay, and what I'll get, the start of the first half is the start of the original, end of the first half will be something else. I'll find that out, but let's first find the start of the second half, which is the midpoint between 128 and 255 on the second octet. And you can do that easily. 128 plus 255 minus 128 plus 1 divided by 2, which is 64. So 128 plus 64 gives you 192. So start of the second half would be here 192. Okay, end of the second half is of course the end of the original block. Now we can find out the end of the first half as one address before this address, which is 191.255.255. Alright, if you didn't understand, let me know. If you have a question, let me know. Thank you.